Good day everybody, we are expected to integrate integral dx divided by x squared positive x positive 1 raised to the power of 2. Now this is a challenging question. Why it is challenging? Because the likelihood of people committing mistake is very high. I will show you the place where people will make mistakes. So having mentioned that, foremost my objective is to rewrite the denominator as a perfect square. So let me just take x squared positive x positive 1. I'm going to write this as x positive. Can I write it as x positive 1 over 2 raised to the power of 2? If I were to expand this, I would get x squared positive 2 times x times 1 over 2. That would give me a x followed by 1 over 2 raised to the power of 2. That's going to be 1 over 4. I need to have a 1 here. I got the first term, the second term, but I need to have the 1 over there. So that is achieved by adding 3 over 4. So this in turn would mean I can rewrite this entire term to be as x positive 1 over 2 raised to the power of 2 positive root of 3 over 2 raised to the power of 2. So this is the perfect way to represent x squared positive x positive 1 as a sum of perfect squares. So having got that, I'm going to rewrite the given question as integral dx divided by, in place of the denominator, that's going to be x positive 1 over 2 raised to the power of 2 positive root of 3 over 2 raised to the power of 2, and this in turn has to be raised to the power of 2. Now let me make a substitution. Let x positive 1 over 2 be equal to root of 3 over 2 times tan theta. If I were to differentiate the left side, it's going to be dx is equal to root of 3 over 2 times differential of tan theta is secant squared theta times d theta. So this integral is rewritten as, in place of dx, I'm going to substitute root of 3 over 2 times secant squared theta times d theta divided by, in place of x positive 1 over 2, I'm going to substitute root of 3 over 2 tan theta, that has to be raised to the power of 2, plus root of 3 over 2 raised to the power of 2. This in turn is raised to the power of 2. Now this can be rewritten as root of 3 over 2. Now follow this way of writing, because this is the important point where people will make mistake. Because this root of 3 over 2 has a square here, and this entire component is raised to the power of another square. So they will skip the square and simply take root of 3 over 2 raised to the power of 2 out and proceed with the question. So that would give an incorrect solution. So to avoid that, what I'm going to do is I'm going to take root of 3 over 2, I'm going to square that, and I'm going to take this out of the parenthesis, but before that I will place a parenthesis in front of root of 3 over 2. Now this is going to be tan squared theta plus root of 3 over 2 raised to the power of 2 is taken out, so that's going to be 1 there. So we close the parenthesis. This entire thing is raised to the power of 2. So this in turn would mean that this 2 is hitting root of 3 over 2 raised to the power of 2 also. So this can be rewritten as root of 3 over 2. Now if I were to apply this square, this is going to be integral 1 over root of 3 over 2 raised to the power of 2 raised to the power of 2. That's going to be 4 there. And you got secant squared theta d theta divided by, I'm going to write that as 1 positive tan squared theta raised to the power of 2. Now you flip it. If you were to flip it, you get root of 3 over 2. This is going to be 2 raised to the power of 4 divided by root of 3 times root of 3 and then root of 3 times root of 3, right? Because it's root of 3 raised to the power of 4. So I can cancel this one root of 3 out, and that would mean root of 3 into root of 3, that's going to give me 3. But 2 and 2 can be cancelled. Of course I need to place that integral secant squared theta d theta divided by 1 positive tan squared theta raised to the power of 2. So this simplification would lead me 2 to the power of 3, that's going to be 8. Now root of 3 into root of 3, that's going to be 3 there, and I have a root 3 there, so just place that root 3. Now fair enough, this is what I have got. Now is there any other any other steps that we have to be bothered about. Okay, so having got that, now let me just move on in simplifying this term. 1 positive tan square theta. That simplification is critical. So we know that secant square theta negative tan square theta is equal to 1. So from here secant square theta is equal to 1 positive tan square theta. So I'm going to substitute in place of 1 positive tan square theta secant square theta. So this is going to be integral secant square theta divided by, in place of 1 positive tan square theta, is going to be secant square theta raised to the power of 2 times d theta. So this is rewritten as 8 over 3 times root 3 times, I can cancel a secant square theta and secant square theta, giving me d theta divided by secant square theta, right? But we know that secant theta is equal to 1 over cos theta. So if I were to substitute, I get 8 over 3 times root of 3 integral d theta divided by 1 over cos square theta. You flip it, this is going to give you 8 over 3 into root 3 times cos square theta times d theta. Okay, now we know that cos square theta is equal to 1 positive cos 2 theta divided by 2. So I can replace that 8 over 3 into root of 3, and that is going to be product multiplied with 1 positive cos 2 theta divided by 2 times d theta. Now 2 divides here 4 times, so you have 4 over 3 into root of 3. Now what I can do is I can distribute this d theta, so that's going to be d theta there, positive integral cos 2 theta times d theta. Okay, so this is what I've got. I hope you got the glimpse of it. So now let me move on to the next page, and so this is equal to 4 over 3 times root of 3 integral of d theta. Integral of d theta will give you theta, plus integral of cos 2 theta will give you sin 2 theta. Coefficient of theta is 2. So this is what we got. But we started with this substitution. What is the substitution? We took let x positive 1 over 2 be is equal to root of 3 over 2 times tan theta. We need theta, so you cross multiply. So this is going to be 2 times x positive 1 over 2 is equal to root of 3 times tan theta. You distribute 2 inside, you get 2x positive 1 is equal to root of 3 times tan theta. Bring this root 3 down, so you get 2x positive 1 divided by root of 3 is equal to tan theta. So this is a very important value for tan theta. Just have it in one corner. Now we need theta, so therefore from here theta is equal to tan inverse of 2x positive 1 divided by root 3. So I can take this value and substitute it here. This is going to be 4 over 3 times root 3. In place of theta, I'm going to substitute tan inverse of 2x positive 1 divided by root 3, plus I got sin 2 theta. I know sin 2 theta as a formula, which is 2 times sin theta cos theta. So substitute that, I get 2 times sin theta cos theta divided by 2. 2 gets cancelled, giving me 4 over 3 times root 3 times tan inverse of 2x positive 1 over root 3 positive sin theta times cos theta. Now we know the value of tan theta is equal to 2x positive 1 over root 3. So what we have to do is we will have to utilize that. So draw the right triangle. This is theta, this is opposite side, this is adjacent side, this is hypotenuse side. Now we know that tan theta is 2x positive 1 divided by root 3. So opposite side over adjacent. So this is 2x positive 1 divided by root 3. By Pythagoras theorem, what do we know? By Pythagoras theorem, we know that AB squared plus BC squared is equal to AC squared. So AB squared is root of 3 raised to the power of 2. My BC squared is 2x positive 1 raised to the power of 2. This is my AC squared. You expand this, this is 4x squared plus 4x plus 1. Root of 3 squared is going to be 3 is equal to AC squared. So I can write AC squared is equal to 4x squared plus 4x plus 4. I can take 4 out. This is going to be x squared positive x positive 1. I need only AC. So AC is equal to root of 4 times of x squared positive x positive 1, which is equal to 2 times root of x squared positive x positive 1. This is my hypotenuse value. So 2 times root of x squared positive x positive 1. Now we need cos theta. Cos theta is equal to adjacent side by hypotenuse side. Adjacent side is root of 3. Hypotenuse side is 2 times root of x squared positive x positive 1. Now my sin theta is opposite side by hypotenuse. My opposite side is 2x positive 1, right? 2x positive 1. My hypotenuse side is 2 times root of x squared plus x plus 1. So this is going to be 2 times root of x squared positive x positive 1. This is my sin theta. Now take the cos theta, sin theta and substitute it here. So that would mean if I were to take this as 2, right, I'm taking this as 2, so 2 can be rewritten as 4 over 3 into root 3 times tan inverse of 2x positive 1 divided by root 3 positive sin theta is 2x positive 1 divided by 2 times root of x squared positive x positive 1 times cos theta is root of 3 over 2 times root of x squared positive x positive 1. Okay, now 2 to 4 root of x squared positive x positive 1 times root of x squared positive x positive 1, they can be simplified. So you got 4 over 3 times root of 3 times tan inverse of 2x positive 1 divided by root of 3 positive root of 3 times 2x positive 1 divided by, this is going to be 2 into 2. So that's going to be 4, right? So 4 times x squared positive x positive 1. This is what we've got. Now if I can simplify this, I can rewrite this further. If you want, you can rewrite it, or you can simply leave it as it is, because I was trying to rewrite it as a perfect square, but it doesn't matter. Now let me bring this 4 over root of 3 times 3 inside. Let me distribute this. So if you were to distribute this, this is going to be 4 times 3 into root of 3 tan inverse of 2x positive 1 divided by root 3, that's one value, plus 4 into 3 into root of 3, root 3 gets cancelled, giving you 4 over 4 can also be cancelled. See, when it comes over here, this 4 gets cancelled. So let me write that down. 4 into root of 3 times root of 3 into 4 times 2x positive 1 divided by x squared positive x positive 1, right? So this is equal to 4 can be cancelled, root of 3 can be cancelled, giving us 4 over 3 into root of 3 tan inverse of 2x positive 1 divided by root 3 positive 1 over 3 times 2x positive 1 divided by x squared positive x positive 1 plus arbitrary constant c. This is the solution for this beautiful question, right? So this is a lovely question. You can work this out, you can check the solution with your solution, and if your solution agrees with this solution, then you can give yourself a tap on your shoulders. Okay, so this is the correct solution for this question. Of course, you can simplify this if you want, taking the root 3 out of the denominator by multiplying and dividing by root 3, but that doesn't matter. So this is the final solution, and we started this question in this fashion. Okay. and then we have to extract the value of sine 2 theta, and then we completed the solution. Thank you everybody. Please like, share and subscribe to our channel. Until we meet again, enjoy.